in order to catch the click, I can use something called a mouse area. A mouse area is something that will catch the mouse inputs. And you can say, in that case, we also have support for encores. Encores, it's a bit complex to show on a demo, but it could have been, encores is something convenient for, let's say, x0, and then y0, and, sorry, y0, and then width parent dot width, and then height dot parent dot height. It's to fill actually so that the mouse area will actually take this, will be the size of the parent. It's just convenience, and it's actually faster. So here, and what you can do is like on the mouse area you got a signal which is unclicked, and then you can do so a rectangle here. It has a state property, and you can actually change it and say state receive show text, right? So whenever I click on the button, it will actually change the state, right? That's what it means. Let's say run it. Okay, so we have it. Then I click, and it doesn't work. What I did. So demo effect would have been perfect if it was working. Show state, show text. Target my Alex. Well, then you should have worked. Trash icon, opacity 1. Let me see, perhaps I click on the wrong button. Well, strange. But, oh yeah. Yeah, that's my bad actually. It's because here, that will work. Yeah. So here the problem I had is like I said state receive show text, but I was actually changing the state of the mouse area, which is wrong. I want to change the state of the button rectangle. So again, when I click, then the trash can disappear and then the text appear, right? So that's quite basic, but it's convenient to use. It's like way easier than C++, right? Then now you can say, okay, let's declare some transition, put a bit of fanciness in our button. So you can same create transitions. Transitions, yes, same. It's an array, so you can create several transitions. So let's create one transitions from state normal to show text, and then I can say, so that's the transition, right? I say when we change from the default text to show text, then I will do something. And in our case, I want to do an animation, property animation. So a nice feature of Qt Creator is like this. So you get a built-in editor. If, oh, sorry, it show up on the right side, so you can see it. But yeah, you get an editor for setting your property animation. So in that case, so I'll show you in the help. Property animation. You can set up the properties you want to act on, and then the easing curve. I'll skip the easing curve, it's a bit more advanced, so properties. And then I say opacity. And then I say on target. And in our case, it's, let's say, on the text, right? So remove text. And then I can say duration. Let's put 600 milliseconds. So if I run, oops, I got a mistype somewhere. Opacity, oops. Syntax error. Oh yeah. Type too fast. Here. So you see the animation, right? The opacity animation. So I can actually increase the length so you will see it better. Here. So here. So you have, as you can see, it's super easy to create states and transition like never in Qt, because in C++ it would have been way more line of code for doing that. So here we only have 75 line of code for this button. So let's go back to the presentation. QML is also really web oriented. Just not because it's JavaScript. You can import pretty much any JavaScript library. It has SVG support. You can render any SVG, PNG, JPEG, everything that is in Qt pretty much. The JavaScript implementation in QML is actually using JavaScript Core, which is the JavaScript engine of WebKit. This might change. We're actually researching using V8, which is the JavaScript engine for Chrome, Google Chrome, and Chromium. It also has support for XML HTTP requests, for AJAX functionality, kind of things. You get also like the same concept as a div ID on the web, which is via item. Item is just an empty element that paints nothing, but you can do some logic inside, same as div. In QML, you can access to the parents of an element, you can access to the children of an element, and similar to what you have in CSS. So you can react to parent change and everything. You can anchor the items together. So anchoring is like when you connect lines. So you say on the left side, on the left side of my parent, then my children will be connected on his left side, and it's the anchor concept. Well, I won't enter in the details, but that's exactly the same as the web. You get also a synchronous API for of the HTML5 web database API, so you can do actually a bit of web database in QML. But as I said, since it's very extensible in C++, you can actually create your C++ class, and that will do the job for you, and use it inside QML. So here is like a list of the default elements that we have in QML. I won't go into details, but that's already quite a lot. And we are going to add more. So a bit of details. QML is a description of an object tree, exactly like HTML, with properties, exactly like HTML. You can bind the properties in between them. So for instance, you can say, like I can show you, actually, it would be easier to understand. I can say here, instead of the trash icon being width 22, I can say the trash icon is bind to the button rectangle width, for instance. So I can say, so it will be 100, right? So if I say width, then it will bind the width of the image of the trash icon to the button rectangle width, which will probably be ugly, but you'll get the concept. You see? So you can bind property in between them, and then we build dependencies and everything and update the properties if they need. If whenever the button rectangle size change, then the trash icon will be updated as well. So the QML engine itself, you can do, of course, script execution, so your JavaScript via JavaScript Core, as I said. You can have network access through HTTP, URI, XML, HTTP requests, etc. Everything you have in Qt, pretty much. You got also built-in support for loading custom libraries. So let's say you have libraries with all your C++ objects that you export in QML, then the QML engine is able to load that library and make everything that you can access in QML your object that you declare in your C++ library. We also have debugging tooling. You can inspect the property. It's also built in Qt Creator. You can debug a QML application, and then you can put breakpoints and see, oh, okay, what happened to that property. You can also have frame rate tracing, so you can know how fast it runs, and console output, just to name a few. And it also has a parser interface. So if you want to extend the QML language by yourself by creating custom keywords or stuff like that, you can actually inherit from the parser interface and add your custom keywords, for instance. So the class you want to see is actually a QDeclarative engine, QDeclarative components, and QObject. Now let's talk a bit about the C++ bindings. So you can expose, as I said, since the beginning, your C++ to QML. Why we let people to do that? It's because we still think that there are parts of an application that you can't do in JavaScript, neither in QML. I don't know, connecting to a highly secured VPN environment, or a database that is not supported by Qt, or whatever reason, or I don't know, algorithm too complex to put in JavaScript, so it's faster in C++. Then we still think that you should be able to use them from QML. But we still think that the C++ is like when you hit the wall with QML and you say, I can't. So then you fall back to C++. That's how we think it should be used. So in order to use any C++ object, they have to be QObjects, which is the base class of Qt. It shouldn't be abstract, so I mean you can instantiate the object. And it should have a default constructor. That's the only 3 requirements you need to do. And then you need to do a bit of work, which is using those 2. First is a macro that you put on your H file of your class, where you actually declare the type to QML via this macro, QML declare type. And then in whatever main or constructor, you actually register the type into QML by giving him a name and a versioning number, like a minor version and a minor version, and also the name that he will have in QML, because you can have the name in C++, right, which can be class foo, but you sometimes don't want to call it foo inside QML, so you can actually change the name here as well. And so the small piece of code that I wrote afterwards is the way you can expose a C++ instance to QML. So let's say you have a declarative view, which is what you see on the screen, right? You get the context. It's called the declarative context. And then on the context, you can set a context property and say the background color inside my QML file will actually be this C++ object, which in that case is a QColor, but it can be anything, right? So you can say, let's say the image had a property called foo. Then you can say set context property foo, and then give the foo instance that you have instantiated in C++. That's one way. There is another way also. So as I say, contexts are key for correct behavior, for scope resolution and everything. Everything is documented. I just introduced everything. So it's easy to integrate with existing Qt UI code. I'll actually show you how you can do it. Let's say I have a C++ code called custom item here. So it's a QGraphics widget, right? So it's a QObject. As you can see here, it has a property color. It has a default constructor, non-abstract, and getter setter for the color. A pen function and a signal whenever the color change, as a private member of the color, and we don't care of the rest. Implementation is straightforward. By default, it's yellow, right? On the paint, I just set the brush and I just draw a rectangle, right? So it will be a yellow rectangle, unless I change the color, right?